In this video, I will show you how to make your own compact antennas for the 433 MHz band. We will be making antennas like this. The coaxial cable acts as a matching element. It's important to maintain the correct dimensions. Deviation in cable length will shift the antenna's resonant frequency. I use this matrix. It's important that your matrix has a hex key marked 0.128. This is a very cheap crimping tool. I couldn't find one cheaper. You can use a soldering iron like this one, but it's important that you have a comfortable soldering iron for the SMA connector's center conductor. Tweezers, a third hand, two cables. One is an RF 1.37mm cable, which I bought with a pre-crimped IPEX1 connector. I use this interface on mobile devices. I've included all the links in the manufacturing instructions. The second cable is an RG316 cable, which we will crimp ourselves. You can also buy one pre-crimped. I use these vertically polarized spring antennas. They say they are for 433 MHz. That's true. Please note that not all antennas from the same seller match the advertised 433 MHz frequency. Only buy these spring antennas. Antennas with different parameters will be for different frequencies, even if they say 433 MHz. This is an SMA Male connector specifically for RG316 cable. I'll be removing the insulation with a scalpel. I installed a new sharp blade. I finished the assembly. I am filming this the next day. The liquid insulation has already dried. These are the antennas we have. Now let's test them. I'll connect the antennas to the Nano VNA device and see at what frequencies we get resonance. We will be using this antenna handled on a radio command transmitter, so measurements will be more accurate than holding the device in your hands. You can see that the antenna's resonant frequency changed depending on the conditions. However, under almost all conditions, it changed toward the calculated value. For this antenna, the SWR varies from 1.3 to 2.1 depending on the conditions. However, there are conditions where the antenna achieves an SWR of less than 1.2. I'll connect the second antenna. The SWR here isn't much different from the previous one. This is because I made the cable slightly longer than usual, which caused the SWR to shift to lower frequencies. This antenna will be installed in a mobile device. It will be located close to the ground, which will shift its SWR. Conclusion: as you can see, the resonance of our antennas fluctuates between 425 428 MHz depending on the environment. This is not a calculated value. However, please note that as transmission conditions deteriorate, the resonant frequency shift toward the calculated 433 MHz. This is good. As you can see, the frequency does not shift for the worse. This means that the antennas will receive and transmit better as the environment deteriorates. However, you can shorten the cables by 2-4 mm and the resonant frequency will be around 433 MHz. Remember that the antennas are vertically polarized and must be positioned symmetrically during transmission. That's all for now. Thank you for your attention. Subscribe to the channel and give it a like. I'll soon make a video about the receiver and transmitter using these antennas.